Alrighty, good evening, everybody. Welcome to our third presentation of the day here for the RSN Spring Conferences presented by WPI. My name is Francis O'Rourke. I'm going to be your host here today and for the rest of the week. Joining me today, we've got Ben Martin. Ben, why don't you tell us a little bit about yourself?
Awesome. Thanks, Francis. So I'm Ben. I've had about 16 years in FRC now.
Wow.
Currently, yeah, it's been quite a while. I mentor teams 225 and 2481. I'm actually more local with 2481. Slowly but surely moving away from 225, even though I haven't been there for like 4 years. Still do a lot of design work with them, but yeah, super excited to be here. The other thing I'm maybe known for is I started the first Capital RA3D. It's been quite a ride. Lots of experience with COTS. Excited about talk about COTS today.
Well, that's good because today your presentation is going to be on using consumer COTS, or what's maybe you've heard of as consumer off-the-shelf items, effectively and efficiently for teams. So that's going to be really, really cool. So again, I want to just shout out some of the people who make this possible, and that's WPI. WPI, or Worcester Polytechnic Institute. They were the first university to offer not only a bachelor's, but also an MS and a PhD in robotics engineering. They've been a big sponsor and supporter of FIRST for a very long time. Learn more about WPI by going to wpi.edu and check it out. One more thing before we get going. We are taking questions from the chat. So if you're watching here live and you've got a question for Ben, or you're thinking about something and you want to ask Ben about it, just type !Q in the chat, followed by your question, and then we will pull that question out. And if we like it, we'll ask Ben live on the air. So with that all said, I think what we'll do is we will get started here. So Ben, why don't you go ahead and take it away?
Awesome. Thanks, Francis. Just quick technical question. Are you sharing it on your end, or should I just go through it simultaneously?
Why don't we just go through it at the same time?
Okay, sounds good. All right. So going ahead and just to start out, like we were talking about, we got we're talking about COTS today. So using COTS resources to improve your competition performance as your team. Go ahead, go to the next slide, Francis. Okay. So going back to about me here, I think that this one's going to. We talked about this a little bit already. The other one thing I want to hit on here is I'm pretty big into the strategy side of things. It's what I do for the day job. It's what I've done for quite a while in the FRC space. And privilege of working at CAT and corporate strategy with that. And I hope that as I go through this on the COTS side, I really want to look into how the strategy of everything is incorporated into what COTS you select, how you build your robot, what's pretty much the whole holistic approach of how everything comes together for that. So moving on to the next slide, Francis. So it should say building with COTS and minimal machining at the top. So with this idea here, when the robot that you see there, that's the RA3D robot that I helped work with this last year. So that's the first Capital RA3D team. So actually, real quick, Francis, I'm looking at this and I'm still seeing the main slide on the stream over here.
Yes, we're gonna do a quick fix for that, everybody. So Ben, if you want to keep talking about this wonderful robot, we're gonna put our lovely faces on screen for just a second while I fix this minor technical glitch I got going on here.
Yeah, apologies for that, everyone. It's probably because of why it seems so awkward here, trying to figure out what's going on with the screen while at the same time watching to see what slides up. So I'm trying to, as I
you're doing great, dude. Don't worry.
Here. Okay,
you're doing great.
Yeah, I continue to ad lib here. Okay, so one of the really cool things about COTS, and as we talk about COTS here, is you can kind of buy your way out of the problem. Would be one way of looking at it. So the more that FRC continues to get bigger and we have more stuff going on, like the more COTS become a regular thing that you could just go to random vendor and purchase things, and there are more vendors and there's more options available. So it's easier to find the COTS to optimize your robot to build better robots. And it really has helped in numerous ways to raise the floor of FRC teams. So I don't think I talk about the history of COTS here in the presentation much. So let me just talk about that for a little bit. So it really started out, some of the first COTS that were available. If you go back pre 2005, that's when you start getting in the era where stuff was limited on the robots. And, besides having limited motors, it was, you even go back far enough and you had to only have parts that were available to you in the small parts catalog. So as we've continued to move forward and FRC's allowed more and more materials available, more and more COTS vendors have showed up. So it really started a lot with AndyMark and the Gen 2 shifter, Gen 1 and Gen 2 shifter, and then the Omni wheels that they had in the early days. So those were some of the first products that they offered that really weren't super accessible to teams, that you could just purchase off the shelf and incorporate in your robot. That obviously that's evolved so much since then, as people have started to realize that there's a lot more available and a lot more opportunity to sell these parts specific to the FRC market. So that's when we've started to see that Vex Pro came in at 2013, and then Rev came shortly after. And then from there, we've also seen other vendors pop up like West Coast Products and Thrifty Bot and Swift and Refire Solutions and Playing with Fusion. And there's a whole numerous long list of FRC vendors that have come into being since then, that we've seen really start to take over this market and provide great solutions for teams. We're good to go. All right, awesome. Yeah, I see that we're over here on the screen now. So thanks for doing that.
And thank you for being patient, and thank you for everybody watching for being patient as well. I really appreciate it.
Yes, really, really appreciate it. Hope you liked my little spiel there about just the history of COTS. That's probably should have led with that anyway.
Actually, I really did, because I do also remember being a student on a team back in like 2005, 2006, and seeing these AndyMark shifters kind of appear out of nowhere. I'm like, what's an AndyMark, right? And then,
Yeah, I was on 234 back in 2005 to 2008, and in 06, we actually used one of the Gen 2 shifters on the robot. So, been a user ever since the very beginning, especially even in 2005, we used some of AndyMark's Omni wheels because our robot couldn't turn and we needed to turn. So we purchased some Omni wheels for it. So been a user ever since the beginning, big believer in making sure that COTS are a thing. And I think that they really help raise the floor for teams. Go ahead and move on to the next slide. So COTS, like we talked about earlier, stands for commercial off the shelf. So what I've gotten here is some of the definitions coming straight out of the manual. So you can see COTS there. It says commercial off the shelf, a standard non-custom order part commonly available from a vendor for all teams to purchase. That being what a vendor is, right? So a vendor, legitimate business source from COTS that satisfies all criteria listed in the robot construction rules section. And then I've got the section down there for what the overview is. So for our purposes here, we're basically saying a COTS is something that you purchase from a vendor. There's been, some discussion sometimes about like, when does a vendor actually qualify to be a vendor based on availability and things like that. The commonly seen term here is most of those parts end up being legal anyway. So for just what we're going to say here, it's that a COTS is something essentially that's available from a vendor. So go ahead and move on to the next slide. So looking through some of the COTS examples that are available for teams, just outlining what can be COTS. So we've got our major mechanisms. So the pictures I've got there, we've got the AM We got the AM Kitbot chassis there. We've got one of the great elevators, some of the great shooter. Those are all could be possibly be considered major mechanisms. They would be considered parts of COTS, COTS items. So vendor fabricated parts, like we've got hex bearings there, sprockets, something that you purchase as a Markforged print, like the Thrifty Bot Mecanum wheels. Those are all COTS as well. Mechanical power systems, like the motors that we purchase, the motors plus gearboxes that we purchase. You see, we've got a Falcon 500 motor down there, Evo shifter, one of the Rev Ultra Planetaries with one of their FTC motors attached to it. And then on the sensor side, you've got your sensor software hardware products like the Limelight. You've got if you add an additional VRM to your robot, that would be considered a COTS item here. If you've got kit of parts items like that Rev color sensor here, technically it's a COTS item too, even though it's in the kit of parts. So it really encompasses basically everything that's coming from vendors that's prefabricated and put together. That's not necessarily like a raw material, like a raw stock. Which it's in itself could be called a COTS item too if you use it in its whole entity, in its whole self. So really anything you purchase from a vendor, it's that you end up using on your robot basically as a COTS item. Go ahead and move on to the next slide.
Yeah, and just to really quickly mention, when you say major mechanisms, that's a rule. That's a thing that's referenced in the rules, correct? We're sort of referencing here.
Yes, that being referenced in the rules, and also it's referenced in the definitions too. So you can read in that about what's considered a major mechanism, and it tends to be kind of ambiguous about something that could accomplish the game challenge. So you really have to read the Q&A each year to understand what is a major mechanism. So I don't really want to get into all the bomb rules and the cheesecaking stuff.
Oh yeah, totally.
And that sort of thing. But yes, it makes sense to understand what the rules for major mechanisms are each year, just to make sure you're on the up and up for understanding what's going on in that space. So this slide here, keep in mind that the content here is my opinion, so take that for what you will. I think these are the most important resources for team competitiveness in order, if I was to stack rank them all. So number one being FRC specific knowledge and knowing what the program is, how the program works, the stupid little details about like if you do X and Y, then you should do Z. Like one example would be how to handle when you're at an event and working with other teams and how to interact with those teams and that sort of thing. That'd be FRC specific knowledge, or what's available in terms of the COTS resources, like what you're learning about right here. That would also be FRC specific knowledge. So knowing stuff that's specifically applicable to the program and used for the program, that's very context based. That's be what that is. Time. So that being the number of hours that you have to build the robot, days to build the robot. Time is your number two resource. And money and inventory, the parts that you have available, would be number three. So below that, you've got your non-FRC specific knowledge. So like your general knowledge of controls, mechanical systems, knowing how to CAD, knowing those sorts of things, knowing how structures work for when you've got a robot and you've got an arm and you want to figure out, say, is it going to break if it hits the wall or something of that nature? Or is it going to break if another robot hits me? Is my robot going to fall apart? That sort of stuff is important, but it's a lot lower on the list compared to these top three. Space to practice being number 5 and machining resources being number 6. So your ability to make more creative things than maybe necessarily putting a bunch of COTS together. So I really think that COTS can help cover gaps in number 4 and number 6. I know they have for me in the various places that I've used this, especially in the time aspect. I can tell you for sure that these RA3D robots have not been possible without having extensive use of COTS in order to get that done. So I think it's very important to look at COTS as a way to fill your gaps in the other areas that you don't have. And sometimes it's easier just to chase down a few extra $1,000 than it is to try and bolster your, say, your machining resources or your knowledge or those sorts of things, and you could just buy your way out of the problem. Just want to make sure that's highlighted here, that this is really where they can find a sweet spot. Let's go ahead, go to the next slide. So covering COTS versus custom machining. So when you look at this is just kind of a slide I put together to say, like, to show where, where COTS are going to give you versus what custom is going to get you. So stuff takes COTS are going to save you time to make and time to design. I know I can CAD up with the students COTS robot much faster than we could a custom machining robot, because a lot of the parts you could just download straight up, and you don't have to spend as much time at the computer designing and figuring things out, as long as you just kind of, you're working within the constraints that you have and figure out a way to make it work with the COTS that you have. So COTS, obviously, here also, they require less expertise to get right the first time. So as good as you are with your machine, you got to get to like a certain level before you can make something work right the first time. You're going to save time with COTS. You just are. You might not necessarily reach the optimized 100% level, but you might get to the 90% level much faster than you will with the custom route. It usually doesn't require special tooling and machines in order to get the COTS up and running as much. Sometimes that's not necessarily true, but it's going to help you a lot in that particular space. There's a money saver there. However, there's probably a money loss in higher component cost. And with that, you don't necessarily get to optimize your space as much, and you don't get to optimize your weight as much. So you get some stuff and you lose some stuff by going with COTS. So it's a trade-off back and forth, so that you have to do that as you analyze what you do. I know that every year on all the teams I'm involved with, there's always that analysis with everything about whether you just buy your way out of the problem or you design something custom in order to make it work. So it works both ways. There's a time and place for both. So let's move on to the next slide. So just to highlight, this is the RA3D robot for First Capital that I worked with 2 years ago. So for the for deep space. So just highlighting some of the COTS that are present in this. Basically, the robot is almost all COTS and parts cobbled from prior robots. So you could see some of the sample ones there. We got KOP electrical system and wire throughout it. We've got the pre-stretched high-strength chain, COTS frame and gussets, COTS wheels, COTS gearboxes. We got sprocket side, the COTS sprockets. We've got, the list goes on. COTS elevator kits, COTS bearing blocks, COTS squishy wheels for pulling stuff in, COTS pneumatic cylinders for actuating stuff out. When you actually come down to it, it's just a lot of smaller raw material items that end up actually make up the structure, and then most of everything else that goes into this ends up being COTS.
And can I
go to the next slide?
Yeah,
go ahead.
Yeah, just really to break in really quickly. Something that maybe people who haven't done FRC or FIRST for a long time might not realize. You've been doing it for 16 years. I'm in the same realm. There was a period of time before what we like wheels have mostly always been COTS, like off the shelf. But there was a time before they had wheels that were like designed for FIRST robots, right? They were just like literally wheelchair wheels you would just sort of slap on, or teams would cut them out of wood, right? And it's which is wild to think of now, but it's crazy how far we've come.
Yeah, I remember back in 2005 when we just had squishy pneumatic tires, essentially from Harbor Freight, that were put onto the robot on the side, or like 2006 when we basically had a tank tread purchased from England that was brought in, and then people had to hack their hack a hub together to basically run the track over.
Yep.
And then it was a very real problem with a lot of stuff just breaking because things weren't made to fit against each other. Yeah, it's my how far we come, right?
Yep.
Yeah, or when people had to machine their own sprockets.
Oh,
I
yes.
mean, yeah, yeah. These days it's very different. That's for sure. All right. So now, just to juxtapose, I think many of you may be familiar with this robot. So this is 254's Lockdown. Just wanted to highlight some of the COTS that we see in this robot too, just to show that all the way up to the highest levels in a robot that went undefeated in the regular season, you still have the COTS going on here. We've got aluminum. It's not square tube; it's rectangular tube. My bad there. COTS drag chain, COTS wheels on the intake, COTS sprockets right there, the kitted parts pneumatic tanks. It just goes to show you that even when you get to those levels, when you get to some of those main core materials, a lot of teams, the easiest thing is just to go the COTS route and just make sure you're designing around COTS every step of the way, unless you really think you're seriously going to get a serious competitive advantage for not doing it. And that's getting a lot harder these days. You got to look to something like 125's wheels from this past year's robot to look at, if you really want to get to the world of redesigning the wheel. You want to go to the next slide? All right. So when you look at this robot, I don't know if you believe it here. It's just literally a worm gearbox, a pinchy gripper, and some can grabbers on the back, and it's still figured out how to win 5 competitions, including off seasons, and it's basically COTS. Um, so it ends up being a lot more about skill and optimizing the rest of your build season and what you're actually going after to do than it does sometimes around the robot itself, and just having a minimally competitive robot that can hack that can hack through the respective game challenge but still get picked high. That ends up being what's most important here. When we look at this robot, granted some of the COTS were modified, like there was one of the raw AndyMark raw boxes at the bottom that has a worm gear on it, that we took out the shaft and shoved a shaft all the way across the bottom of the robot with. But the vast majority of the rest of this is basically COTS stuff, maybe with a hole or two drilled in it, except for the gripper had a lot more holes drilled in it in order to lighten it. But it ultimately comes back to just making sure that you have that you try to optimize for speed and get stuff out the door as fast as possible, and iterate on it from there. Unless you've really got that ability to get to that tippy top level, this is going to get you 95-99% of the way there sometimes. All right, moving to the next slide. Now, next, we're going to cover COTS in mechanisms. So I'm going to go through a lot of the core FRC mechanisms, and we are going to look at how COTS are incorporated and ways to incorporate COTS, and just some of that FRC tacit knowledge that I talked about before, as much as I can offload here about designing these different types of mechanisms and incorporating COTS into them, and how you can save time in your build. Okay, looking at load ratings, let's go to the next slide. So what we have here with this one is, I just want to make sure everyone knows that when you're dealing, especially with these planetary gearboxes or the worm gearbox that I talked about earlier, you want to make sure that you read the load ratings and understand the load ratings. So they're probably going to be in foot-pounds or ounce inches or one of these torque measurements. And you want to make sure that you don't put enough load on your gearbox that you're going to cause a breakage. So you see, in this particular case of Versa Planetary, they're very good about publishing their load ratings, and you can keep an eye on those to know exactly what motors you can use in what instance. So you have to keep an eye on both sides of the gearbox, both the input side and the output side. You don't want to overload your gearbox with like an arm at the end where you pull down on it, and then with a long lever arm it causes a breakage, or you don't want to load it on the motor side too much, putting in too much motor power, or like a too powerful of a motor, and then put too much reduction, so by the time it gets to the end of the gearbox it's applying so much force to the end that it causes a breakage on the gearbox. Now if anyone, if I said any of that incorrect, feel free in the chat to correct me on that end, because I am industrial engineering background versus mechanical, and I have a tendency sometimes to get some of the terminology wrong. But the basic gist of this is stuff you don't necessarily need to have a mechanical background to fully understand. If you could do a little bit of math and make sure that you're not applying too much force to it, you should be in a good position. You want to go ahead and move to the next slide, Francis? Okay, so now I'm going to start going through some of the individual COTS items. One of the items that's often underrated, kit apart chassis. There are some elements of it that kind of reduce your amount of flexibility that you're able to have, in that you're kind of constrained to some of the wheel positions that you have there, but there are many ways to modify the kit of parts chassis to get it to do what you need to do, and it's certainly going to speed up your drivetrain build using this more than any other option that you've got. So with that, there's numerous upgrade kits that are available. We've got eight pneumatic wheels. You've got Mecanum wheels. If it's a game like 2015 again, and you want to use those for that. You've got that you see down here. There's a Thrifty Bot plate that you can buy that makes it so you could put 3 motors on it now. So then that makes it so you could do 3 brushless motors, like a few top teams did this year on your drivetrain. So there's it gets to the point that you basically have all your plates set up, and then you're just basically struggling with figuring out how to mount stuff to the top of it. In those cases, which isn't near as bad of a problem as sometimes screwing up a hole in your drivetrain when you're building a custom one, or even with some of the more flexible custom drivetrains, messing something up there and getting something wrong and then having to redo it. Here, this is a much cheaper option, and you've got quite a few options to modify it. There's even a kit to make it so you can move the front plate back, so you can have an open area in the front too. So for some of those games where you need to have game pieces pull in the front and then pull up over it. So it's super useful. Just most teams, you don't want to. There's teams that discount it offhand every year, and you don't want to be the team that totally discounts the kit of parts chassis, because there's plenty of great utility here for a lot of teams. You want to go ahead and go to the next slide. So then when we look at the Versa chassis next, so this is one of the other very popular options. I myself, with 225, have essentially used a version of the Versa chassis every year since 2014. And then before that, it was the Kitbot. But the nice thing about it is it allows you to be very free with where you put your wheels and holes, that you can basically take a hole saw or a stepper bit, put a fat hole through the side of the frame in each of the wheel locations approximately, and then you use these bearing blocks which you put a bearing in each side, and then it's a live axle system for transmitting power to one side or the other of your drivetrain. And you power all your wheels. You can make some of them Omni wheels. You can make pneumatic wheels. A whole bunch of different options, and it gives your drivetrain can be as long as you need it or as thin as you need it, and it still can work out. So it's and use whatever transmission that you can that interfaces well with the blocks or with the side of your frame. All of that is possible, and it's a very flexible system to use. It does have some weight stuff that you have to be careful of, in that you're adding a lot of these bearing blocks, and that's heavier than you'd be with the case of like the kit of parts chassis. but does increase your flexibility and where you can put things, and it's very easy to tension your chain in that it's got those cams in there that you can just take a 3/8 wrench and then twist the cam to tension your chains at each particular leg. So that's useful. I've got over there a couple photos. So you've got the Vex Pro 3 sim ball shifter is one of the common uses until we got to the brushless motors, and then the utility of shifting starts going down a little bit. But um, that's one of the common options that up to this point that could interface super well, and it attaches nicely to the bearing blocks. And then I have a West Coast Products one there too. With these flip gearboxes becoming more popular, a lot of the Vex gearboxes also have the holes that interface well with the bearing blocks that make it easy to attach these to your robot. So bunch of options here. You get all the benefits of a West Coast drive that you're able to detach the wheels very easily and pull the wheels off. Um, and then service them and put them back on. So it gets the chassis becomes very easy to service, which is nice. Um, all right, let's go ahead and move on to the next slide.
And just to break in really quick too is
Yeah.
that we on my team 190, we've been using the Versa blocks for I think 3 seasons now, and
Hmm.
to your point about weight, it's definitely one of those concerns. But
Hmm.
we basically, the fact that we are able to offload so much of our, we make a lot of custom parts on our team, but not having to make custom bearing blocks and super precision shafts and everything like that saves us so much time using this that we are able to do a lot of other things in cool parts.
Yeah, for sure. And I mean, things like those bearing blocks, we've used them on arms, we've used them on numerous different locations. We've used them on elevators. It's the pretty much the biggest disadvantage of them, besides the weight, is just that it's a $30 bomb item.
Yes.
Um, but that's kind of what you got to deal with. It's an expensive part to make, so it's understood. But they are very useful. And then the fact that the center drop is built right in there, that you can drop a 16th inch by turning them one way for the center, and then they go up a 16th inch on the outsides by turning them the other way, is just it's a useful thing for teams to have in the toolbox. And if you're not looking at these now for whatever application that you have, it certainly makes it a lot faster to make tensionable chain runs on whatever mechanism that you're doing very quickly. Yeah. All right. So moving on to this next slide. So I have some of the swerve options that are available on the market right now, up here right now. I haven't actually used any of these, but I have used Swerve through 2481. So I could speak a little bit to what's important. A lot of these you've seen great success from many teams here, like to name them off. Andy Mark, I believe, was used by 3707. It might have been a modified version. I don't know for sure, but they won worlds last year. 1323 won worlds last year with one of the West Coast product versions here. The SS one, I believe, is new. Someone correct me in the chat if I'm wrong. And then the Swerve Drive Specialties one, I mean, Jack and the Bot did amazing last year with that one there. So there's a lot of battle testing that goes on in these swerves, and just keeping uh it's not as hard to do swerve as it used to be. It's more of a learning curve around the programming side, and making sure that you've got the training on that end, and then just hitting the purchase button on the COTS end, and you can get something that's almost as good as something you design yourself for much faster. Um so so keeping these in mind, it adds to the price a little bit, not a lot. But really it's about getting the utility of swerve, and then you could just bolt it on some 2x1 tube and go from there. um all right, go ahead and move on to the next slide. So let's talk about elevators. So when we're looking at elevators, pretty a lot of vendors have elevator kits. They're all a little bit different. It kind of depends on what you're going after. And I think some of them have kind of seen iterations over several years. So if we going back, one of the first ones out was the Vex Pro one. So that one came out in 2015 here, in response to the 2015 game. Um, so it uses some of the smaller bearings and really is gets you some of the plates, and they sell some of the bearings too and some of the spacers, but then you have to get some of the bolts from other locations. So it's not necessarily a fully encompassing elevator kit. It is a little bit on the sloppy end too, but one of the nice parts of it is you can actually it's built so you can, if you're making a single stage elevator, especially, you can go to the some of the plates that they have for the inside. You can actually sandwich the whole piece of the whole elevator between two sets of bearings in the left right direction, which is not something that you can necessarily do with every elevator kit. So that's kind of nice. Um, the West Coast Products one, the Great Elevator. So that one's come out in the last couple of years here. It's more of a more of a full direction elevator kit while still making it flexible enough for whatever the game is, that some of the core dimensions you can adjust on your own. It's nice because they've done some of the systems integration work for you, that they've got a place for the motor to mount, so it makes it a lot easier for teams that especially don't have experience with this sort of thing, that they can put together that whole side of things and know what to do, and it makes it a lot easier for them. So it's nice that that one's around. Oh, you've also got the Andy Mark one. So this one's a little bit beefier than some of the others. It's got the plates that have both the front, back, and the left right bearings are integrated on the same plate, which is useful for strength and rigidity sometimes. When you're dealing with these elevator kits, one of the things that you need to make sure is you minimize the slot between the bearing and the tube. I haven't had a whole lot of issues with the Andy Mark kit. Used it in 2018. Did a good job when we were using 0.1 tube with it. There's the Rev one. I don't have as much experience with this one, but this one's they use Rev's extrusion system, and you've got V bearings that essentially run on that, to, if I remember correctly. So it's a system for this too. A new one that is out is the Competition Robot Parts one. This one looks kind of cool. Haven't necessarily seen it yet, used it yet, but it seems nice because it's very low profile. It's got and one of the things that you, just as an aside, one of the things that you want to watch in elevators, especially when you're purchasing your COTS, is you want to try to get as much travel as you can, because you want to get a little bit more height to get to wherever you need it. And sometimes the elevator kits don't necessarily do the best job in making it so you've got that height available to you. So you have to keep an eye on that when you're purchasing your elevator kits, and look at a couple different options. So with the Competition Robot Parts one, it's got both the left, right, and the front, back bearings integrated into the same piece, which is nice here because it really makes a lot more lower profile. And you could potentially make your elevator go up an extra inch or two, which is nice. So a lot of the easy one for most teams to do is the cascade rigging. So for those of you who aren't familiar with that, I think that there's a image that floats around on Chief Delphi, and I think it's been in several of Andy Baker's presentations and things of that nature. But with the cascade style, you're having your second stage or your third stage, or however many stages you have, being lifted relative to the prior stage. So there's essentially a rope that runs up to the top and then down to the prior stage, or to like a fixed point on the prior stage. And then so it essentially uses the rope length in order to force the next stage up, versus the continuous style, which like 148 and 1678, if you've looked at a couple of them here, they've essentially have one spool, and then the whole thing, the cable runs through the entire elevator. So I consult those CADs there for looking at continuous rigging. It's probably one of the easier ways to do it. Look at like their 2018 CAD, 2019 CAD. they'll be helpful for understanding how that works. I know that others who've looked at 148s, one CAD for 2018, to learn how to do continuous rigging. I've only ever done the Cascade myself, mostly because it's easier and faster from my perspective. But there are strategic advantages to doing it with the continuous style, especially if you want to just lift your gripper first before you lift the rest of your elevator. It's more useful for that. If you're doing Cascade style and you're using chain on it, like what you see over there with the grade elevator, um, you'll want to what you can do with that is you could do number 4 bolts for number 25 chain, or number 8 bolts for number 35 chain, and that will cover it for you. If you need them, constant force springs, but we got so much motor power these days that sometimes you can get away without it if your elevator's light enough. That's elevators in a nutshell from a COTS perspective. It's one of the popular mechanisms to have as COTS. Let's move on to the next slide, unless you got anything, Francis. All right. So I've got a couple slides on arms and wrists, kind of putting them as a catch-all here. It's basically rotary joints. They can. It used to be that the elevator was the harder mechanism to do. Now I think the arm has become the harder mechanism to do. Just because there's more thought that needs to go into weight and things of that nature. Whereas with the elevator, you can kind of buy an elevator off the shelf, and you don't have to worry too much about how much your moment is on your mechanism, and instead you can worry about just getting it to go up and down, and those problems you don't have to worry about as much. So um, the number one advice always with the arms is you want to minimize what is on the end as much as possible, because it just makes your life far more difficult control wise, especially when you're dealing with a heavy weight that's swinging around at different heights and has different amounts that it's counterbalanced at each point. I've found gas shocks to be one of the easiest ways to counterbalance arms, and just designing them in from the front end is probably good to do. Like you see that 254 arm right there. They've got gas shocks attached to that sprocket to help counterbalance it. And then you probably want some sort of absolute control mechanism, like a potentiometer or an absolute encoder or something of that nature, um, to to keep track of the rotation of your arm, so that when you lose power, you remember exactly where it is. Because far too many times, unlike with an elevator where you can just drop it to the bottom and let it and start it from there, with the arms, you've got to be careful with when you bring it up to a position. It could start from a multitude of different positions, especially with some robots, unless you have like a hard stop to push it against. And also, in case your robot reboots while on the field, you don't need to have special code checks or things of that nature in order to figure it out. You could just, have whatever your absolute control attached to it, and then you can go from there. So just something to be aware of when you're designing these arm mechanisms. Also, I've got in there some cool stuff that's come out recently. There's a West Coast Products gearbox that actually has an integrated brake into it, so that's nice. On the pneumatic side, on for the from Andy Mark, you can buy the darts. I've used them before. There were a couple eccentricities had to deal with back when I used them. I hear they're better, but basically that's a lead screw. You need to be careful about sticking it at the end, so you definitely want to make sure that you've got good control on them. Um, because if you overshoot with the motor and the lead screw gets stuck at the end, that tends to not be in a good position if it gets stuck or it gets stuck down. So you have to make sure you got good control on that. But that's another option if you don't just want to use, say, a pneumatic cylinder for 2 positions, or you want to use something like that for your arm. I will say the lead screws do a very good job of making sure your arm is steady when it's up, so you don't need to have something like a counterbalance from a gas shock or anything like that. They do a very good job of keeping things rock solid steady when they're up and not bouncing. You want to move to the next slide? Okay. Some other stuff I want to talk about here. On the right side, we've got this is from 525 in 2015. I'm doing it in arms, even though it was kind of used in more of an elevator application. But this is just showing how the disc brakes work. Some teams, I know 1678 used them in 2016, I believe. But a few teams use them here. It's basically what you do is if you have one of these disc brakes, you can attach it to one of the shafts. Some of them have hole patterns that are similar to a standard hub pattern. Then you run the disc brake back to a pneumatic cylinder, and the pneumatic cylinder tightens around the brake or pulls the cable, and then the brake tightens around the disc brake, so it can help hold stuff in place. Whether you need to, so you could use it on an elevator if you need an elevator to hold up, or you could use it on an arm if you need to hold an arm up. It's one other way of doing that to prevent your arm from drifting down.
Real quick question:
Yeah,
that brake, where would you get one of those? Is that just literally like from a bicycle?
you could do it from a bike shop. I've never actually used them myself, but I wanted to make sure I highlighted them because a lot of teams do use them. I've seen quite a few of them on Amazon, considered purchasing before. That you just, yeah, it's just a brake from a bicycle that you put the whole system in there and then shorten the cable and then use a pneumatic cylinder to pull the cable to basically tighten the brake around. But yeah, that's essentially what it is. And some of them have hole patterns that are very close to a standard FRC 1.875 hole pattern, or 1 and 7/8, sorry, 1 and 7/8 hole pattern. Yeah. Um, the other one I wanted to highlight on here. So with 5406 picture that we've got here, the reason I brought that one up is they've got a cool mechanism in here that they're actually using a chain to lift their second stage of arms. So it kind of becomes like a 4-bar mechanism. So where you're, for everyone who's not familiar with 4 bars, it's the when you have like another linkage on top of the linkage that's turning to basically hold whatever mechanism it is up straight. Now it's obviously not moving in a 4-bar motion in this particular case, but it's useful because what you can do is you can power up something like that second set of arms just by you do the rotation at the back set, and then this chain run is essentially running down from a bigger sprocket to a little sprocket, um, or whatever config that you want. And so as one is turning, that sprocket turns to raise the arms. Um, so just highlighting another couple cool things you can do here with some relatively simple components to pull some cool stuff off. Next slide. All right. Another one I want to talk about here is you don't necessarily power your arm off of the main stationary thing. You can power it off the thing that's rotating. So that's what you see in the image on the left. So that's 225's intake from this year, where we didn't have space to put the motor on the inside, so we put it on the gripper. So that basically the rotating thing, the sprocket that's attached to the upright there, that one's just stationary, and the motor on top is what rotates. So it basically rotates, and that bottom sprocket stationary, and it still brings things in. Obviously, you've got to deal with wire management, but it's another technique you can do. On the robot on the right, just highlighting here, sometimes you've got multiple stages of arms that you're working with. And for each stage that you're going out, you're going to need to probably, if the more weight is held out from the robot, the more you have to be ready to address forces and such that are gravity that's going to want to pull your arm down. So for instance, this was 2019. The arm on the inside, those motors, we had two 775 Pros, and the one on the outside, that was just a bag motor. So just highlighting a little bit on power difference needed. So go ahead and move to the next slide. All right. Don't want to spend too much time on intakes because I think that they're already pretty popular, and I think that there's a lot of options that are available out there right now. Um, it is different between round objects and square objects. So when you're dealing with these square objects, we've usually got the side intakes like 2018 and 2015, especially when you're trying to drop the square object down square, like we have in these games. That's where we've seen a lot of these side intakes. For balls, the top intakes seem to typically be better. It's usually better because sometimes there's stuff on the field and then you have to run over it and then pull the stuff in. The Now that we've got a nice mix of mini Mecanum wheels, mini Omni wheels, mini squishy wheels, mini hard wheels, basically everything under the sun, it becomes pretty much a task of just whatever the game piece is, just mix and match and try to figure out what works best in that particular case. So you see the two RA3D robots on the far left, where we basically just mix and match small wheels until we found something that worked really good. The one in the middle, that's 5254. I want to highlight that one there because they ended up, especially for IRI, turning that robot into a robot that was essentially built of almost completely all COTS into something that was intaking similar to that 1114 robot on the right, one of the best robots of the year in 2015. So sometimes it's about knowing the config that you need to do and then just buying the COTS components that can get there, and you can get almost to the level of what those really good robots are doing just by purchasing these components. Let's go ahead and move to the next slide. So looking at turrets, the big things you wanna make sure with, you want to make sure your backlash is limited, and you want management. So you can do that with wire sheathing or energy chain, and strategic placement of surgical tubing, and there's a bunch of stuff you can do for that one. You're probably not gonna get the full rotation, especially with the amount of stuff that we need to take up to our turrets these years, like vision stuff and limelights and multiple motors and things like that. Um, but there are a couple COTS options out there that are available. We've got the Armabot one up here. We've got the Great Turret from West Coast Products up here. The you, with the backlash, when there's a couple places it can be in whatever cabling you're running around your turret, if you're doing chain or if you're doing making like a turret gear or something like that. I know this past year 225 basically water jetted a turret gear, and then went that route because that was ultimately simpler and less expensive than going some of these routes based on the resources that we had. But for a lot of teams, like if you're looking at even what what we did in 2013, where you basically buy a ring bearing off McMaster Car or from Amazon and then loop a belt around it and then glue the belt down and then just turn that. Sometimes there's a lot simpler way. They're really simple ways to get turrets done. And if anyone really is curious about how I've built out cheap turrets, feel free to reach out. But I don't want to spend too much time on turrets. But there's a couple cool ways that you can get your turrets done, both either purchasing them this way and just getting rid of the problem that way, or cheaper ways to do it also with especially the Amazon ring bearings are really inexpensive.
Yeah, I was gonna say actually that's how we
Yeah.
did it with our robot this past year. Is we bought I think it was $17 on Amazon. It was a ring bearing.
Mhm.
It certainly wouldn't have hold up to too much force or too fast of a rate of rotation, but it had holes in it. We slapped a plate on top of it, and boom, we were good to go.
They are really easy to use.
Yeah,
Like it was very, very surprising. Like turrets don't need to be hard for teams. The harder part ends up being just how it ends up being the backlash in the motor, to
yeah,
be quite honest with you.
yep.
Yeah. Yeah. All right. Going on to the next slide. Um, like the turrets, I don't want to spend too much time on ball management because it really varies year to year. In that the Spindexers this year were very different from what we saw in 2017. I've got two 2017 robots up here. Um, but it's almost always the thing that you really want to prototype and hack at for most of the season, because there's not necessarily a cookie cutter way to do it. Um, but just to highlight a couple of the common methods, the one on the right is basically that's McMaster flat belting on a bottom powered by a 775 Pro motor that sped it into a shooter and then just shot out of there. It's a way of when you're like double shooting or something like that, just brute forcing it. You could probably also shoot them into a linear path, kind of uh, like 118 did that year, with simple belting like that, and run it up to a shooter that way, to single file things. Um, it, it's it it gets the job done, especially if you're looking for an easy way of getting out of the problem. It's not going to get you to the 100% level, but it might get you to the 90% level. Um, and if looking at the 973 one, so that one worlds, if you they've got a bunch of other custom complex stuff on there, but if you actually just look at the system that is doing the indexing of the balls and passing them in, it's basically a stick going down with some surgical tubing rack spinning down there at the bottom. So just goes to show you, sometimes you just need something that spins in a circle and then just kick it in there. Let's go to the next slide. So looking at shooters, a couple good robots on here. The 2056 one, that one highlights, I think better than a lot of the ones I've seen here, just how useful the rails are. It's very good to have a couple rails when you're shooting. Or in the case of like the 2481 one over there, we actually have a crown instead, so the ball follows the crown. But something like that to keep the ball centered left to right. Um, Besides all the other shooter stuff that you need to worry about, like making sure the control's consistent, and the feed's consistent, and the optimum compression, and all the normal shooter details that you need to hack at most of the season for any given year. Just making sure those balls are centered. There's not really a good COT solution for that. There is the West Coast Products, the Great Shooter down here has a backing on it. Wish it had a rail, because we found they tend to be very helpful for making sure your left right is nice. But if you don't need to worry about left right that much, good option, just purchase something like the Great Shooter and go that route. But there's a couple. There's definitely numerous shooter wheels. It you could This is shooter's one of those things that you could make your side plates out of wood if you really needed to. It's really comes down to making sure that your rail's consistent, make sure the feed's consistent, and all that stuff. Um, let's move on to the next
Yeah.
slide.
Before we go, really quick, I just want to
Yeah.
point out 2481. Their shooter is a bicycle wheel. And
Yes.
when I saw the reveal video, it was about the wildest video I've seen in a long time with respect to like not expecting to see something that massive on a FRC robot.
Yeah, shooting the degloved ball, right?
Yeah, exactly, right?
There's there was that's the result of lots of testing, probably about like 5 weeks of prototyping just
Wow.
on like shooter wheels. Yes.
That's great.
Yes, it was a fun build season. Shame we don't get to see it out there.
Well,
But
you never know. We'll see what happens in the off season. We'll see, right?
I hope so. That robot needs to see the field.
Yeah.
It's a fun robot. Um all right. So looking at some of our off the beaten path COTS. So this is just some of the stuff I've stumbled along the given years that's not necessarily sold at one of the major vendors. So we just want to make sure it's highlighted. Besides some of the stuff is more known, like the Automation Direct, and I think Andy Mark sells them now. Different components for the pneumatic system and making your gauges small and reducing weight that way. Um, this is a few of the ones that I've ran into here. So this Adafruit IR beam brake sensor, it was 650. Works great for ball indexing. Um, haven't ran into issues with that. Was very pleased with that. I found that when I came to 2481 and they were using this thing. I was like, oh, that's cool. Um, Thomas,
Can I break in real quick
yeah,
because
yeah,
I've always been using for that kind of stuff. My team's always been using the old banner sensors we used to get in the kit of parts in the day.
yeah.
How does this compare to those kind of things? They just as good? You see?
Well, this one's got more of a defined range, I would say. So it was
Okay.
useful in putting in a ball path.
Yep.
I still use the banner sensors too quite frequently, especially like 225s use them for forever. Um, and they're especially for ball intaking. The for when you pull something in, right, and then you
Right.
adjust the little screw on top, and then it comes in, and then you so you know the position, so you know when something's intaked, and then you can turn the intake off, right?
Okay.
That's where I've used those more. I used one of the I actually used one of those Rockwell sensors for catching um back in 2014
Oh wow.
also. Yeah. So when the ball comes in and then you close it, and then you have to be very specific, obviously, with the with the little screw thing that's on top to get it to the right position. Um, so it's nice when you have to tune it, in my opinion, and it's nice also that you don't need to put something on the backside. But if you want a super cheap option, this is a nice one I found that I thought this was pretty cool.
Yeah.
Yeah. So I didn't put links in here because I figured this is being presented. So I tried to make everything very Googleable as much as I could. Um, so we'll try from there. But um, the Thomas 215 compressor, it's a nice. It's about 3 pounds. It's a nice balance of flow rate and also how much it heats up. First ran into this one when I saw a 254 was using it in 2014, and used it ever since. To be honest, it's a nice little compressor that seems to do the job pretty well. And every now and then, like the ones that we got, you see, I found put the cheapest one that I could find online there at 150. The ones I found, we've got like six of them off eBay one time for like $50. So you can hunt down and find those alternative sources also. Um, Turntable bearing, we talked about them. They're multiple sizes. They're very useful this year from Amazon. Um, you can wrap chain around it and then attach that chain, or you can um, wrap a belt around it and turn it essentially into a gear. Or in our case, like we water jetted a turret gear and put it on top. Um, if you've got the sponsors to do that,
Wow.
so
Pretty cool.
yeah, yeah, it's they work pretty good. Um, there are a couple of those cases where sometimes it's easier just to do the custom machining, especially if you're only making one part.
Yeah. Yep.
It becomes a lot easier. For everyone who doesn't build their own PWMs and cut their PWMs to size, you could do that. Hanson Hobbies sells that stuff. I put the 150 kit on there. It's got probably more than you need, so you could probably buy things piecemeal. But it's I've been a fan for the longest time of just making your own PWMs and putting them to size. It is a little more custom, but it's the same way every time, and it makes you don't have wires flopping around everywhere.
And once you've got the tools, if you ever need shells or pins, you can use the PDV from DigiKey to buy more of the.
That's a good point, and everyone should do that here. Um, all right, looking at this relief valve from McMaster, I ran into this one at inspector training, actually, that they were saying everyone should use one of these relief valves. So essentially, what it is it's already preset to 125, and then you just put it in place of your existing relief valve, and you don't need to turn the current one. And it's only like $5. So it seems to be a nice option for people. Plus, it's also an air release too that you could just pull the pin.
Now, I hate to put the inspector onus on you, right? But
Yeah.
you would still need a dump valve on your system if you had this on.
Yes. Yeah. You'd still want your dump valve,
Okay, cool.
but yeah, but this is you're probably not going to do it with that, but yes, you'd want to still want a dump valve.
Cool.
I should be caveating that I'm an LRI, so
Okay, cool.
be careful. But yeah, I got that one in inspector training. Um, so and then we use this chain from for 225 anyway, from Roller Chains for Less. It's preloaded roller chain. I spelled chain wrong, unfortunately. But yeah, it's actually, oh, it's covered by the WPI logo. Looking over here at the stream. Okay, you don't even see that. All right.
I see it. It's
But
there. Trust me. Nothing's wrong. Totally fine.
preloaded roller chain. Yeah.
Yes.
Yeah. So this stuff's nice because it's pre-stretched for you. So you're not get that initial stretch that you might get from some of the FRC vendors. So we've been very happy with that here, and it's I don't think I saw Donnie's in chat. Let us. I'm pretty sure we haven't busted a chain in like 2 years, and we played like 20 events with that. But he can correct me if I'm wrong here. Let's move on to the next slide. All right. So I see I'm running closer on time here, so I'll try to speed along. But I'm going to talk a little bit about optimizing the build with COTS. So this is just some general tidbits going along about when you're dealing with a primarily COTS robot, how you want to structure how you do things. Okay. So one thing you want to worry about is standardizing. So 225 standardizes on Neos right now, standardized on CTRE stuff. Depends on how you want to do this. There's different teams like different products for what they're doing. If you try to move around something that's a little more standard, you're probably going to run you're going to put yourself in a position that you know how the thing works and you can deal with its eccentricities when they come up. And standard operating procedures, SOPs. So many of us in industry are familiar with that. For those of you who are not, it's basically you've got a process for how to do something and you go through that process. Now, with that caveat, obviously, you don't want to over standardize to improve your competitive performance. You don't want standards for the sake of having standards. You want standards because they make things easier for you. So moving on to the next slide. This would be a standard operating procedure for making accurate chop saw cuts on for 225. So there's always a little bit anxious with the chop saw that if you're not holding something wrong, it can fly back in your face. So we're very careful with who gets to use the chop saw in our case. So how we work that through, especially when we're cutting metal. So the student gets a drawing of where the part measurement should be. Student gets material and marks the location. Another student double checks them, hand it to a mentor. Mentor makes the cut where the student had it, and then the student checks that the mentor actually cut it correctly. So it becomes it's not necessarily documented anywhere besides the word of mouth here, but it's outlined that it's the process. This is how the process works. Follow the process every time, and then we could get a repeatable result each time. So especially when it's something like this that it's pretty cut and dry and linear. That's kind of how we're doing this and what we do going forward.
And just real quick,
Yeah.
do you have any experience with using cold saws to cut aluminum or something like that? I've seen some teams use them, and they say they're a lot safer.
They are, and I agree that they. The problem is they're a little more on the expensive side
Right.
than just having a chop saw like this. So I used one when I was with 3504 briefly, and they had a cold saw there. A big fan of the cold saw. I
Yeah.
love the cold saw. I think that they're very useful for the teams to have. The problem is it's a little more expensive.
Yeah.
So, yeah. Yeah, whereas a chop saw is a lot more in the achievable range for teams. So what we do in our case is it's kind of the compromise that if there's a big rotary disc that we have, then the students generally do the marking and the mentors do the cutting. And then if we're dealing with something like the mill or the CNC or things of that nature, then it's more student jobs on the cutting.
That makes
So,
sense.
every team has it their own way. So the students are still kind of outlining how the part's made, and then
Yeah, I mean,
the actual cutting operation's done in this way.
yeah, I'm in charge of
Yeah,
safety for my team, and I
yeah,
generally have a similar policy there, where if we don't know safety, the safety SAS is something we have a mentor with more experience or someone with more experience do it, and then figure out an SOP to bring it down to the students.
yeah, exactly. All right, moving on to the next slide. So, when deciding how you're going to do something, I've got a little bit of a snippet over here from JVN's Week 4 blog. So this is from 2019, where he talks a little bit about how they relied a little bit too much on 3D printing out of the gate in getting stuff together. So it's almost like you got to recognize what your constraints are as you're going through your build. Know what your machine is going to be the bottleneck, or what person's going to be the bottleneck in terms of you need specialized skills for something, so that you can parallel process as much as possible and get things done as fast as possible. Um, so you see some of the key questions over there to the side. How long is this going to take to make? How do we get it done correctly the first time? Can we get it done faster and easier? What's the bottleneck in your process right now? And one of the nice things about COTS is they can definitely minimize the time to make and the time to design and things of that nature, even if you're punting a little bit on achieving the 99.999% robot. Instead, you're getting the 99% robot. So let's go ahead and move to the next slide. So pointing out CAD for 2 past years for 2 robots. Um, so when you're looking at this, a lot of the stuff is just COTS components that were downloaded, and then even the custom stuff that you see that's on there, a lot of it has just kind of been thrown in to make sure that there's a placeholder, and some stuff like certain simple spacers and things like that you leave out of it because it ultimately becomes a little bit too much time just to make that thing. Or if you're, say, catting in a piece of 80/20, if you look at um, the 2020 robot there, there's a couple star wheels down at the beginning of the indexer that are basically serializing the balls. There's a little tiny piece of 80/20 that's coming out of the um, side of the serializer there to hold those star wheels, that bracket in place. And I mean, that's just a block that's sitting there, and it's just called 80/20. So sometimes what you want to do is you just want to get the core dimensions in so that you can figure out what the problem actually is, so you can get to making as quickly as possible.
You've taken the 80/20 approach to 80/20.
Yeah, essentially. Yeah. That's one way of looking at it. Yeah. All right, let's move on. All right. So if you have no CNC, there's a nice easy way to do it. If you're not aware of this method, hope to make you aware of it now. You can print your CAD drawing out on a 1-to-1 scale. You cut it out with a pair of scissors, tape it to the part. You center punch all the holes, drill all the holes through, cut around the edge of the part. And you look at this robot over here. Basically, that whole back climber was basically made that way because the mill was constrained at the time. So it was just if you need to make custom gussets, you can make custom gussets that way. Um, you just highlighting out there that there's a bunch of ways to make simple stuff that way. I made a whole, like, with a few of the students, we did a whole bevel geared with some custom taps um, color wheel mechanism this past year, a prior iteration of the one you saw in that picture, that basically used this method for the entire thing, and it was accurate enough, and got the holes lined up and everything, and it still works. So just highlighting, sometimes it's not necessarily going to be right 100% the first time if you make a mistake doing it, but it's certainly going to make your accuracy a lot better than just totally freehanding if you don't print it. Um, let's move to the next slide. All right, so the bread and butter of COTS building is planetary transmissions. So we got a bunch of options available these days. The nice thing about the Vex ones is they can go to pretty much almost any ratio, and you can swap them out super easily. Nice thing about the Andy Mark ones is they're pretty sturdy and bulletproof. Nice thing about the Rev one over here is it's super light. The cartridges can be swapped out, so I think they've got a 3, a 4, and a 5. So you've got a couple different options available on that one. And but it only works for 500 series motors. So understanding your planetaries and what you want to use for those is pretty important, because almost always with your mechanisms, the first stage is when you're building like with these with COTS, the first stage is almost always going to be a planetary. So you just have, except your drivetrain. So you just have to make sure that you're you know what's available, how to package them, how to put them in, what their load ratings are, especially what their load ratings are, and that you follow them. It's probably going to, like if you're an ARM, you'll follow up with a sprocket reduction or something like that, so it can take some shock loads. So, just understand your planetaries and work through them that way. Let's move on. So we talked about clamping gearboxes a little bit earlier. So I've got the Vex Pro one on the right side. That one's plastic. It works good in a lot of situations. I've actually, in some cases, we've actually copied the profile of it and built it into a metal version that was custom, just using the same type of profile, because it's such a useful thing to be able to just clamp around a piece of tube, and then you can move it with a cam to tension your chain and have all your gear reduction taken care of. It's very nice. Highlighting that those just the clamping bearing blocks on the left side, that they can be used in other locations here. That's a 2016 robot right there with a big arm that was lifted by darts. So down at the bottom there's actually four. Well, it's 3 of those clamping bearing blocks there. There's one that's around the arm for securing that. And there's also one on each side of the arm as well, to basically be bearing blocks for holding this mega arm. So these things aren't just useful in the drivetrain. You can use them in other spots, just as to help be bearing blocks for you. So let's move on to the next slide. Want to talk a little bit about 80/20 for everyone who wants to use that stuff. We use 80/20 less and less each year, but it was certainly super useful when we were starting out and building things with COTS with less resources than we had right now. So you can look at that robot. The thrower's made of 80/20. The drive is made of VersaFrame, but 80/20 is actually used as the bumper mounts. So you can drill tap the top of those there and put a little bolt sticking out of it, and it makes a very easy bumper mount for West Coast drives, which is kind of cool, especially if you've got the 2-inch spacing out, like we do there. So it's nice for that.
And
the
really,
half by go ahead.
I wanted to say, actually, I'm pretty sure that one of 225's robot is actually in the 80/20 catalog.
Really?
Yeah, actually, I got a catalog the other day, and I saw one of 225's robots in there from, I think, 2014 or something like that. So
it's probably this one. I didn't even know.
Yeah. So if
we have an 80/20 distributor. It's one of our sponsors, so that's where we ended up getting a lot of this stuff. So that is kind of cool, I guess.
Yeah, pick up a copy. Take a look.
I'll have to look that up. Yeah. I'm surprised you know that. I don't know that. Wow.
Well, as a hack engineer type myself, 80/20 comes in sometimes. But go ahead. Sorry to interrupt.
Yeah, no problem. Thanks for interjecting that. Yeah, it's probably this one. So there's some other this half by 2 80/20 stuff is very, very interesting, because it's actually has the same weight as the 0.1 VersaFrame. And it's got similar structural, like it doesn't bend very easily. So especially when you're doing something like this and you want to drop something that's smaller for your intake, it was very useful for that. And in certain applications, it seems to be a useful type material to use for structural things that have to go outside your frame. So um, and it for especially some teams with lower resources to not build something, you know, if you want it to like just work and drop it outside your frame, it's something that seems to work pretty good for that. It is obviously heavier, and you run into weight issues if you're not careful. Um, and you have to worry about the T nuts and Loctiting them. Um, so all of that, you just have to be aware of when you're using it. But it's got some applications in FRC, especially with the fact that it has the tapping on top. Um, you now let's just go to the next slide here. Um, I wanted to talk about wood a little bit as well. Um, so you can see that 2013 robot there on the side. That robot has a crap ton of COTS on it too. Kitted parts drivetrain, 1.4 competitions with a wood shooter and a 2010 wheel bracket attached as a motor guard right up there under that bucket.
Wait, so
So
just to be clear, that wood at the top, that was competition right
that was
there?
competition.
Wow.
Yes.
Stick. Did you paint it at least, or?
It did get painted a little bit on the front.
Okay.
Yeah, but the whole thing didn't end up being that way. No, it was a pretty hacky robot built on $1,000, 1.4 comps. It goes to show you a little bit that sometimes you can have some of this easier hack together stuff that just basically came out of the kit of parts, and you can still put together something that's pretty good. We did end up lightening all that stuff up there eventually because the weight was too top heavy, but like at its core, I mean, it was a bunch of cots and cheap stuff hacked together that still managed to do pretty good. But with wood, I think teams shouldn't necessarily like it's not too bad. It's lightweight. You have to be careful if it leaves the frame because it can crack, and then you don't want to have your stuff break. We had a couple issues with this robot falling over and then cracking the wood a couple times and having to fix it. Um, but it's fast and easy to form, especially when you're dealing with large plate parts like this. That we could get these things together much quicker, and this type of robot wouldn't have been possible without it. Moving
And,
on to the next slide. So, electronic rivet gun. We started using this one recently. Super useful. Highly recommend everyone get one because it just makes things so much faster. You don't need to lug your air around. It's easy to use in the pits at competitions. Costs about $200. But its usefulness is just so great that I'd highly recommend that teams look at getting these. Make it very easy to use. I don't know if you've used one, Francis.
I have actually. So up until halfway through the season, we were riveting everything by hand. And then we had a whole bunch of rivets to go on a robot, and I said nope, and drove to Harbor Freight and bought a pneumatic one and a compressor for my cordless drill. So we just moved into the pneumatic age on Team 190. I want one of these, but all of our tools are in the Ryobi or Walt line, so I didn't want to add a third set of batteries into the.
That's fair. We have a DeWalt Mentor, so all of our tools except this one are in the DeWalt line.
Wow, very
Yes.
cool.
Yes. Yeah, it is. It is super. And we've been in the pneumatic age since 2014. And this one is way like I don't want to use the pneumatic one anymore. This one's just way better.
Great. Wow, I can't wait.
To give you a little context there. Yeah. All right. Yeah, so let's move on to the next one. So everyone who doesn't know what 1.125-inch step bits can do, the beautiful thing about these things, you can buy them from the hardware store. Often you can buy them from Amazon. They're the perfect size for the normal FRC bearing hole. So, if you don't have them handy, I'd go out and get one right now. You won't be sorry. It is incredibly useful to have them. It's way better than using a hole saw. And you've got the perfect bearing size to put stuff in. So
now, would you
go for it?
do you use
Go do
this?
it.
Would you use this for like prototyping, or is this part of your strategy of using COTS and quick manufacturing to get things on your production robot faster.
Yeah. I mean, these days, we just got a CNC this year. So the bearing holes will probably be cut out by that in most cases. But before that, like 100%, use this thing all over the place to get your bearing holes in. Certainly on the RA3D robots, for every bearing hole, it's done with one of these things.
Yeah.
Yeah. Yeah. It's nice because you don't need to step up to it. You don't need a big bit. You just go buzz. You put a pilot hole and then you go buzz with this thing and you call it a day. Yeah.
Sweet.
Yeah. Before that, we also used this thing for holes on the Versa frame chassis. We mill those now, but before that, we were using this thing. Okay, so on the next slide, everyone who doesn't use chain also should use these right. I introduced these to 2481 this year, and they quickly bought 2 more. The nice thing about them is you can get rid of the master links forever. You may need to still use the 1.5 links or the half links occasionally to put them in when you're re-riveting chain. But basically, what it does is you push the pin out and then you push the pin back in with the other half of the tool. So you could see that Swift one on the right, where it can push it out, and then you flip the chain over, and you could attach it to another piece or attach it to another piece of chain. Basically, what you do is you push the pin out until it's outside of the inner link, but still inside the outermost link, and then push it back in from there. So you're not actually. Sometimes you'll push the pin all the way out if you want to detach it completely, and sometimes you won't. I hope that makes sense a little bit.
Yeah.
I think there's probably a video out there somewhere that shows how to do this, but yeah, they've got them for 25 and 35 chain. All the major vendors sell them. Highly recommend everyone who doesn't have one go get one.
My one thing to note as well is that if you think you're going to take something on and off multiple times, you may want to wait until you're done doing that before you use this tool, because trying to break the chain with this on the robot can be a bit of a hassle.
Oh yeah, for sure. You definitely want to make sure you can design around taking the detaching the chain. Otherwise, you're probably you're going to be in trouble with this. Yeah. All right, moving on to the next slide. And I think this is my last main slide. Okay, so everyone who's not using drills for tapping, also, I highly recommend you look at doing that. Way better than manually tapping anything, especially when you're like in our case where you use these West Coast Drive axles. These days we're doing a little bit more of using a lathe and putting E-clips on as we've progressed, but this is by far the faster way of doing it. When you probably lose like 1% efficiency in there by the fact that you have a chance that you can compress things down a little bit too much if you do it wrong. But you want to, with the drill tapping here, what you could basically do is you could put a washer and a screw on the end and then sandwich whatever it is. It's super nice for dealing with Churro or Thunder Hex from Vex Pro or things like that, for all the axles around your robot and just attaching them with bolts, and then Loctiting those bolts down. You can also use the drill taps if you're dealing with things like the AndyMark Peanut or 8020, where they've got these holes at the end, and you can just drill tap into that to basically make larger standoffs for whatever it is that you're working on. So lots of utility here with the drill tap. You could do it too if you've got like a piece of plate that you need to put a hole in and then tap through that hole. So many uses here. All right, go ahead and move to the last slide, and we'll be at questions.
All right. Well, hey, that was a lot of fun. Certainly very thorough. You went over a lot of stuff there, which I found really.
Yeah.
But I loved it. I thought it was very interesting.
It was a lot. I know.
Yeah, it was.
There's a ton of stuff in there.
Yeah, it was very interesting. I was very eager to see what was going on. It was a lot of fun. So, but lots of different things to cover. But because of that, we've obviously got lots of different things to talk about. So, if you have a question for Ben, please send it into the chat. Just type in !Q followed by your question, and then we'll catch those questions, save them, and if we like them, we'll put them on the air. And so we've got our first question coming up here. This is from user Crispy Kiwi. He said, they say, do you believe that custom? This is kind of a heavy one to start off with, right? But you believe that custom machining parts adds to the experience of building the robot, or does it not really add any educational value? Maybe one way to put it would be like, I know a lot of people, especially older school people, are big on having the team members build every single aspect of the robot themselves and not buying stuff. What's your take on that?
Yeah, no, that's a great question to lead off, actually. I think it depends on who you are. Like in my case, I came out of the school of industrial engineering and process optimizing. So my undergrad was in industrial engineering, my grad's an MBA. It's so far it's not so far removed from the mechanical stuff, but it's not necessarily what me as a student lighted my fire. And what really got me into it, I was more into the strategy side of things and optimizing the whole process around it. So everyone's got their own thing that they're super into. And from the case of like a team like a 225, let's say, it's more the leadership is more from a standpoint of seeing this as an opportunity of looking at every holistic part of the program versus just looking at necessarily the mechanical parts. So we might lose some on the mechanical side if you're, say, going the COTS route, in terms of the experience that the students might get. But it's not necessarily to say that's all going away or you have to do it on every single component in your system.
Right.
You could say, okay, we're going to make this part custom and this part we're going to use primarily COTS because we're going to get the ROI for going custom on this part is going to be so much greater. Like the Spindexers or things like that of this year that so many teams put together. These more complicated things that you can't put together with COTS. Maybe there's a better, you make custom that thing, but then your drivetrain, you just want to snap your fingers and say like, okay, it's done.
Well, yeah, that's the thing is you got to spend your time on, like, the whole crux of your presentation is spend the time on the things that matter the most. And the other thing too is that, like, we just had a presentation with somebody from WPI Lab who was modeling their drive algorithms, try to get some data back before the robot's built. Because every minute you're faster with building your robot mechanically is 1 minute more the programmers have to do it.
Yep.
All right, we have
to speed up every part of your build process.
Exactly.
Every part.
Exactly.
Yeah.
It's not just about putting pieces together.
Yep.
Another question here we've got. Sometimes I see a COTS part that would need some modification to make work for my desired application. Where do I draw the line where I redesign for like a stock part, or do I go full custom? I see this a lot where people see this thing that's off the shelf and they change it so much. It's like, why didn't you just make?
Yeah, that's a good question. I would say the line is probably drawn for how it really depends on what you're doing, right? Like one example is people modify hubs all the time, right? So you have like an existing stock hub and you need to make it smaller on one face in order to fit into whatever it is that you're building, or maybe take the hub part off completely. But then you run into the problem of, okay, at what point would it be better just to buy raw stock and work through that? Sometimes I would say I wouldn't be afraid of modifying COTS components. I certainly do it all the time. In these cases, I try to minimize the custom operations on it, or make sure that if you're doing a custom operation on it, that you put yourself in a position that you only have to do it once, because you are kind of disrupting your ability to use that COTS component on something else necessarily. So there's no real line for that. It's really you just got to look at what's going to get me to my point that I need to get at the fastest, and that's where you have to look.
Okay, cool.
Yeah.
So we have another question here. This one is from Nuttyman54. They ask, what are some of your favorite COTS items that you find yourself using every year. They add the caveat excluding drivetrain. No cop outs on the kit bot.
No cop outs on the kit bot. I I would say, ooh, what am I using most these days? A lot of versaplanetaries, awful lot of versaplanetaries.
Yep.
It's very hard not to use it because it lets you change the ratio as much as it does, and it's very easy to interface with the hex shaft. I would say that's probably the number one.
Okay, cool.
Yeah.
So on that sort of topic here, we have another question. This one's from Steph Morrison. She asks, what's your number one underrated COTS item? And then she goes on to say that hers are the Andy Mark triangle bumper brackets. Oops, I lied. It's actually the Vex battery box. Number 2 is the bumper bracket.
The 16 tooth number 25 sprocket from Vex.
Wow, that was instantly. What now? Why?
Yeah.
Why a 16 tooth sprocket? Just good sized.
We use between two teams, probably. Well, let's count the R3D team. Between 3 teams, we probably used 70, 75 of those,
Wow.
something like that. Yeah. I really wish there was a bulk purchase item that someone just sold those things for, because it's when you're using chain, if you're using chain, there's not really a better option.
Okay.
Yeah.
Is this for like 1-to-1 drives you're talking about?
Yeah, lots of 1-to-1 drive, and or you've got your VP plugged in one place or whatever gearbox, your hex output shaft, and you're going to another spot, and you have to transmit power for that. That's that would be some of the big ones here. I mean, those used all over the place, especially when you're building in a non-custom world and you need to use lots and lots of chain. It's definitely a common one.
All right.
Yeah.
So we have just a couple of questions left here. So if anybody's got any questions, make sure to send them into the chat sooner than later, before we end for the day here. After the day here. So our next question coming up here, the person asks, do you ever think we'll reach a point where teams can purchase, bolt together an entire robot? I know that not to feed the flames of Chief Delphi here specifically, but people have spoken about this many different times, many different ways. What's your thoughts on if we're ever going to actually get to a point where that's a thing?
No way. There's no way.
No? Why not?
No, I don't think that you can get to the point of bolting together a whole robot, and that's fine. But like you could put together a kit of parts chassis right now, and you'd still have to ultimately cut your belly pan in some way. I mean, and you have to cut your wires still, and like there's no way to snap your fingers and you're not cutting at least some sort of raw material for this. And the bottom line is too, like, you all remember how much you learned putting Legos together? I mean, at some point, there's a lot of kids who learn that way, and you got to start somewhere. And the bolt together stuff, like I was talking here, you can get to a good COT solution that gets you even a 99% robot. You're not going to get to a 99.999% robot without some custom.
Right.
It's just not going to happen.
Well, I think that's part of the thing too, is that like there's a reason that we see teams that are at the top tier using COTS where they can, but also building their own thing, because when you try to apply another design to your design, you're never going to completely reach like fully optimum.
Yeah, exactly.
All right, cool. So yeah. So anyway, with that said, that's all the questions we have for today. I want to say a huge thanks to you, Ben, for going in on that topic. It was awesome to listen to all your thoughts on all the different aspects and parts we've got going on off the shelf components here. And I think I definitely learned a lot that I'm going to I'm going to use when it comes to
Steel's fine.
Yeah.
Yeah. No, take the presentation, do whatever with it. It's all good.
Yeah.
Yeah. And I got to say also, for having me on. Thanks to RSN and WPI as well.
Oh, well,
because it's been a blast. Really enjoyed talking about this stuff. It's one I've wanted to give it chance before. Didn't mind them all here, but then this opportunity showed up, so I thought, yeah, give it a shot.
Well, hey,
talk about COTS.
I think it was a great opportunity. I'm glad you spent the time to put this together. Really, very much. With that said, thank you to everybody for watching. This is going to conclude our broadcast here for the first day of RSN Spring Conferences by WPI. Tomorrow, don't miss it because we have 3 great presentations. We've got first a presentation by Eric Klein. He's from team 2412. He's going to be talking about how to sell your team to the judges and other teams as well. Then we've got one of my favorites, which an older version of this I received when I was in college. This is a presentation on motors and transmissions. If you're ever wondered how exactly you pick a gear ratio, as opposed to just picking numbers randomly, or why a particular motor is good for one thing or another, you definitely want to watch this. That's presented by Professor Kent Stafford from WPI. And last but not least, our premier presentation for the day tomorrow, we've got a talk about FRC game design and a look in at the 2020 game Infinite Recharge, and that's going to be by Jamie Luce. She's the FRC team advocate, and she was the lead for the 2020 game design group. So that should be a lot of fun. You don't want to miss it. Make sure to follow us here to get to know when we go live immediately, or to follow us on social media to get all the updates as the days go on. But last but not least, thank you once again, Ben, and thank you to everybody for watching. And we hope to see you all soon. Thanks so much.
Yeah, thank you.